Hello, grade 11s. Welcome back to the channel, Science Therapy, hosted by the one and only science therapist, Uabudiwasos Ukobela Wemets. And without any further ado, let's look at this question that we have got here. Okay, so we have question 4 on Newton's second law. It says in the diagram below, an 8 kg block is connected to a 4 kg block by means of a light, inextensible string. A constant force of 55 Newton is applied to the 8 kg block to accelerate the combination of blocks to the right. And then just below the diagram there, we have a statement that says the kinetic frictional force between the 4 kg block and the inclined plane is 4 newtons, while the kinetic frictional force between the 8 kg block and the horizontal plane is 8 newtons. Then we have 4.1, it says state Newton's second law of motion in weights. So we know that we are supposed to define that according to our CAPS document. So there we have our definition as it is. It says Newton's second law states that when a net force acts on an object, the object will accelerate in the direction of the net force, and then acceleration is directly proportional to the net force and inversely proportional to the mass of the object. Right, so for 2 marks, that's all you are supposed to write. And then now we have a 4.1. 4.2, it says draw a free body diagram of all forces acting on the 4 kg block, and then we have 4 marks for that. Now, I did mention that you can draw this in 2 different ways. So one is to just go and say, this is your normal force here, and then you have this one here acting down like this, and this will be your gravitational force. So and then up the slope, we have our tension forces. We can see it is being pulled by a rope there or joined by a rope to the 8 kg block. So this is a tension force. And then down the slope, it is the force that opposes the motion of the object, which is the kinetic frictional force, Fk. Then we can indicate that dot there to represent the object. So right, this is one way to draw your free body diagram. But then if you prefer to resolve your weight or gravitational force into components, then this is how you will do it. Now, I always vouched for the one whereby you resolve, because you get to see all the vertical and horizontal forces, which will be able to help you in terms of your calculations. Right, so there we go, like that. And then we have our... So, okay, let me do like this. We have our FG parallel, FG perpendicular, and then FN. This will be FG parallel, and then this will be our kinetic frictional force, and then this will be our tension. Right. Then let's have this. Okay, so let's label. We have a normal force, Fn. We have a Fg perpendicular. Then this is Fg parallel. And then this is your kinetic frictional force. And right here we have tension. So when they mark this one, they mark it as 1, right? So in the memo, you will see them indicate this and then show a mark. Because when you have the Fg parallel and Fg perpendicular, they are components of the Fg. So they represent one force. So these are just 2 vectors. And then this is just one vector that represents the effect or the same effect as the 2 other vectors acting together, right? Okay, so either you draw it like this or you draw it like that, you will get your full 4 marks. Okay, then 4.3, they say calculate the tension in the string connecting the 2 blocks, right? So I did mention that in this kind of questions here, whereby you have a system of blocks, even though they did not ask you to draw the free body diagram of the other block, it is very important that you draw it yourself, right? So make it a point that you also draw the free body diagram of the other object, because you will have to use it eventually. Remember, if this is a system, you need the information from both these diagrams, right? So that means in indicating this one, you would have your forces like that. And then the forces acting on the 8 kg block would be the normal force, the gravitational force, and then you have your force applied, then this is tension, and then this here we have Fk. Now we have the free body diagram of both the 4 kg block and the 8 kg block. Now we are required to calculate the tension in the string connecting the two blocks. Now in a system of blocks, we know that two things are correct. The tension of the two blocks would have to be the same, and also the acceleration of the two blocks would have to be the same. So remember, this is a system, so the acceleration of the 4 kg block would be the same acceleration of the 8 kg block. The tension experienced by the 4 kg block would be the same tension experienced by the 8 kg block, because this is being connected by the same rope, right? Okay, so in calculating this, we need to say for 4 kg block, we are going to have our F net. F net is equals to ma. Then we only consider the forces that are acting parallel to the surface. So in this case, we have the tension in the Fk, but then this is the catch. If you did not resolve, you'd only see tension in Fk. But then if you then think of this, remember every time this is on an incline, your Fg always has components. So this is where now you have to then remind yourself, for the people that do not prefer resolving, this is the catch here. You need to always remember that when calculating your F net, you need to include the Fg parallel. And the Fg parallel is always acting down the slope, or always sliding down the slope. So this is where now you have to remind yourself that there is the components, the Fg perpendicular and Fg parallel. So that means your F net in this case would have to be represented in this manner. Now this is being pulled upward, right? So this is your positive direction, and then this is your negative direction right here. So the positive direction is always the direction of motion, and the negative direction is the opposite direction, right? To the motion that is positive. Then, okay, so this would be tension minus your Fg parallel, and then minus Fk, right? So it's always the positive forces minus all the forces on the negative side, and then is equals to ma. Now we don't have tension, that's what we are trying to calculate, so we'll just write T. But then Fg parallel, we know Fg parallel to be equals to mg sine theta, right? So we have this saved up there, and then this is mass is 4, meant to say. We are dealing with the 4 kg block. So that's 4 times 9.8, and then sine 30 degrees minus Fk. When we read here, they said the kinetic frictional force between the 4 kg block and the inclined plane is 4 newtons. So we have Fk is 4 newtons, and then here we have 4a. Now if you punch all this into our calculator, we'll get T is negative 23.6 minus 23.6 is equals to 4a. Now we can make T the subject of the formula by saying T is equals to 4a plus 23.6. Now we are done with the 4 kg block. Let's now move to the 8 kg block. We'll indicate for 8 kg block. Again, we only focus on the forces that are parallel to the plane, right? So we can see here, these are the forces, force applied, Fk, and tension. Again, this is the positive direction, and what we have here is the negative direction. So that means if we represent our F net, we have F net is equals to ma. This will be force applied minus the Fk minus the tension, ma. Now force applied, as we can see here, is 55 newtons. And then our Fk, when we read here, they said while the kinetic frictional force between the 8 kg block in the horizontal plane is 8 newtons. So we have 8 minus T is equals to 8a. Now 55 minus 8 will give us 47. So 47 minus t is equals to 8a. Now, again, here we can make t the subject of the formula. So 47 minus 8a is equals to t. So simply took this one over to this side, took the 8a over to that side. And then I will call this equation 2, while this I will call it equation 1. So at this point, we can see that we now have two equations which are expressed in the form of t being the subject of the formula, right? So that means right now, because both these expressions are equal to t, that means these expressions are also equal to themselves. So that means we can equate equation 1 and equation 2 because they're all equal to t. So that means in that case, I have 4a plus 23.6 is equals to 47 minus 8a. Now you know your maths. Everything with the variable a will be on the left-hand side. So that's 4a plus 8a. And then here we'll have 47 minus 23.6, right? Now the 4 plus 8 will give us 12a. And then when we subtract here, we have 23.4, which if we divide both sides by 12, so that we have a, our a will be equals to 1.95 meters per second square. But then remember, the goal here is not to find the acceleration, it is to find the tension, right? So what is tension? We can now choose whether we substitute in equation 1 or equation 2, right? So remember, we are trying to calculate the tension in the string connecting the two blocks. And then we did mention that the tension in the 4 kg block is the same tension in the 8 kg block. So it doesn't matter in which equation we substitute in, right? Because we do understand since they are all equal to t, then it doesn't matter whether I substitute in equation 1 or equation 2, I should get the same answer, right? So let's say I choose to substitute in equation 1. This will be t is equals to 4 times 1.95 plus 23.6. And then when you punch that into your calculator, it is supposed to give you 31.4 newtons, which if you substitute in here, I believe it would have to give you more or less the same answer there. So if it's not exactly the same, that means maybe it's because of rounding off, but then I just confirmed it right now. When I punch it also into this equation, I still get 31.4 newtons. Okay, now 4.4 is asking us a question. It says the angle of inclination is decreased to 10 degrees. How will the change affect the coefficient of kinetic friction? Now note this. How will it affect the coefficient of kinetic friction? You will remember me saying that the coefficient of kinetic friction cannot be affected by the angle, right? So whether you increase or decrease the angle, it has no effect on the coefficient of kinetic friction, because the only thing that can change the coefficient of kinetic friction is if you change the whole surface. So here we are just supposed to say it will remain the same. So remains the same. And then we say coefficient of friction, coefficient of kinetic friction, which is your mu k, is not dependent on the angle, is not dependent on the angle of the incline. Right. And then it's not dependent on the angle of the inclined surface. And then mu k, which is the coefficient of kinetic friction, can only be changed by changing the surface. Or maybe you change the material of the surface, right? Because the coefficient of friction speaks to the material of the surface. So like glass, if you have to move this to a glass, then now you have a different coefficient of friction. If now the same incline would have to be made of wood, now it has a different coefficient of friction, right? So it is only having to change the surface or the material that makes the surface the only way in which you can change the coefficient of kinetic friction, right? So with all that being said, guys, please press the thumbs up button if you have enjoyed the lesson and then you found it helpful. And if you've been watching the videos and haven't subscribed yet, please hit that subscribe button. But most importantly, please share the link with your friends and classmates so that they may also find assistance. Remember, do not be selfish. We are winning as a team.